All right, guys, here's your last lesson for the unit. Proving independence. So in the previous lesson, we talked about some formulas for probability. Two of those formulas were formulas when these events were independent. So today we're going to try to prove whether or not two events are independent. The way we're going to do that is we're going to use yesterday's formulas, the first two formulas. And if these formulas check out, meaning that if the formula left side and right side of the equation agree, then we're going to establish independence. If our formulas do not check out, then the two events that we're talking about are not independent. All right, so I've got two examples for you. One of them ends up in independence. The second one ends up in dependence. All right, I misspelled that. Dependent. Okay. So what I'm going to do is I'm going to use one formula for one of them, another formula for the other one. But in theory, right, the way that this works is if two events are truly independent, then any of our two formulas from yesterday will work out for the problem. So what am I talking about? This. Let's say we've got a table. All right. Here's my two-way table. And I've got a chart of males and females and whether or not they passed or failed a test. Okay, so the question, given this table, would you say that the gender of the student and passing or failing are independent? So we can try out our formulas. If our formulas work out, then fantastic. All right, and we're going to want to think of totals here. So what I'm going to do is I'm going to see if the probability of A given B is the same as the probability of A. That was one of my two formulas, right? If these are truly independent, then the probability of A given B is just the probability of A. So I'm going to check this, and you can come up with any example that you want, but I'm going to come up with the example of what's the probability of passing given that you are a male, all right? Well, the probability of passing given that you're a male is going to be, well, 62 passed out of how many males? That 88 males, I believe. So 62 out of 88, I did, and you don't have to add that up in your head. You can use parentheses right here. There's a 70% chance that you're going to pass given that you're a male. Now, I'm going to compare that to the probability of A, which is the probability of passing, the probability of passing in general. So how many people pass? 62 plus 93, that is 155. 155 out of the sum of all of these numbers, right? That's how many people passed. So I'm going to, and it'd be good if you made a totals column for your two-way tables, right? But when I check that fraction out, I get the exact same percentage, 70%. So this means that there is no, that these are independent. There's no dependence between the two events because I got the same percentage. And this would work also if you used your product rule. All right, now let's move on to an example where we will not see independence. All right, again, are gender and passing independent? I'm going to use the product formula for this one. And you're going to use whatever formula your problem guides you to use, all right? It has fill in the blanks. So I'm going to try this with, what's the probability of being female and passing? Being female and passing. So female and passing, that's 37 out of the total. I believe the total is 144 students. So that's 37 out of 144. In other words, about 25.69%. Okay, now we're going to compare that to the probability of being female times the probability of passing. So the probability of being female, that's 51 out of 144. The probability of passing, that is 102 out of 144. If I multiply those two, I get 25.08%, which is very close, but not close enough. Those two percentages are not the same, meaning that these two events are not independent. All right, so basically, if your formulas check out and you get the same result, then independent. If you get two different numbers, they are not independent.